In this video, we are going to do global exception handling with IExceptionHandler interface in Aspnet Core. As you remember that when we are examining this article, which is the handle errors in Aspnet Core, we saw exception handle with lambda functions in the program CS, but one of the best practice is to handle the global exceptions using the IExceptionHandler interface. So IExceptionHandler interface is provided by Aspnet Core and allows developers to handle exceptions globally. It offers a callback method for managing known exceptions, and it can be registered as a service. So IExceptionHandler instances are singleton and can be registered using the add-exception-handler method. This is one of the powerful features that we can register using this add-exception-handler extension method from the service collection. And multiple implementations also can be added and are executed in order of registrations. So if the exception isn't handled by any registered handler, the control falls back to default behavior configured in the middleware. So if you scroll down, you can see that how we can setting up the custom exception handler using the IExceptionHandler interface. And we will also create this kind of custom exception handler, and we will give the name as a custom exception handler, and we will put this class into our building blocks in order to make it available for each microservices. So we will develop global exception handler into the building blocks. We will create custom exception handler that can be used for each microservices for handling exceptions globally. For that purpose, please open the Visual Studio and go to the building blocks, and under the exceptions, I'm going to create a subfolder which name is handler. Add new folder which name is handler, and in the handler class, I'm going to create a new class which name is custom exception handler. So you can come here and see that we have created a new folder under exceptions which name is handler, and create new class which is the custom exception handler. This class will implement IExceptionHandler interface and define our custom logic for handling exceptions. So you can see that we have implemented this interface, but if you try to using and adding this IExceptionHandler into our class, we cannot find the IExceptionHandler. So where is this class and interface defined in ASP.NET Core? If you open the documentation and click the IExceptionHandler, you can see that IExceptionHandler is located under the Microsoft ASP.NET Core Diagnostics namespaces. In order to use ASP.NET Core specific interfaces like IExceptionHandler in this case, we need to reference ASP.NET Core packages. So if you open the Visual Studio, you can see that we cannot find IExceptionHandler in the building blocks because the building blocks is not ASP.NET Web API project. So this class comes from the ASP.NET Core libraries. Since we are in the class library, we cannot access this interface. But we should use ASP.NET Core APIs in a class library in order to avoid duplication of these cross-cutting concerns like exception handling, validation, and so on. So how we can solve this problem? There is a very good solution that we can use. We can install Fluent validation packages that include ASP.NET libraries. We will also use Fluent validation for all microservices. So for that purpose, it is a good way to reaching ASP.NET libraries over the Fluent validation NuGet package. So please come to building blocks and right click and manage NuGet packages. And I'm going to install Fluent validation packages in here to access ASP.NET libraries. Here you can see that Fluent package has 3 packages. We have already installed the dependency injection extension. Now I'm going to install Fluent validation and Fluent validation.asp.NET Core. So please install the first one, and after that please install the third one which is related with the ASP.NET Core. And after that you can double click the building blocks and verify that you have installed these 3 Fluent validation library. These packages will allow us to access ASP.NET Core specific APIs in our class library. Now please save this file and go to the custom exception handler class, and this time if you try to implement this interface, you can see that we will add the using statement which is the ASP.NET Core Diagnostics namespace. Please remove unnecessary using, and we are ready to implement IExceptionHandler. So now we can implement the interface members into our custom exception logic, which is the try handle async method. In this method, our custom handler class will log the exceptions and determine the response based on the exception type and format the response as a problem details object. Let's start the implementation. Our method is try_handle_async and it has different parameters including HTTP context, exception and cancellation token. So we will use these parameters when implementing exceptions globally. I'm going to change HTTP context to make it simple for parameter name, and after that make this function as a async to implement awaitable functions inside of these functions. So now the first step is we are going to log the incoming error from the exception object. Here you can see that I'm going to use logger, so that means I have to inject iLogger interface into my class. For that purpose I'm going to add a primary constructor and passing the iLogger object in here. So we have injected iLogger object, and make sure that your class should be public, not internal, and I'm going to change the access modifier as a public. So now we will continue to implementation our try_handle_async method. After logging the incoming exception with message, I'm going to use C# pattern matching to identify exception type, and after that I will populate the details of these exception values. So let me copy paste, and after that I'm going to explain the code. So here you can see that we are going to use pattern matching, which is a C# feature, and we will identify incoming exception type, and according to this type we will perform some actions. That means I'm going to create an anonymous object that we will populate these details, title and status code values for each switch statement. So first of all, let me implement this validation exception from the Fluent validation, and after that you can see that in every exception type we will specify these parameters including the details as an exception message, and title will be exception type, and status code will be identified according to incoming exception type. If the exception is internal server error, we set the status code as a 500, and if the exception is bad request, for example, we status code 400 bad request. So if you scroll down, you can see that there is a discard character. That means if the exception is not including these types, the rest of the exception types will be available with these codes. We will give a detail and title, and status code could be 500 internal server error. So after defining these values as a details, we can specify our problem details to identify the whole exception as a problem detail. You can see that I have created problem detail and give the title detail status from the detail object that we have created in the previous code, and instance comes from the context object, which comes from the HTTP context object. And after identifying and creating problem details, we can add more custom problem details as an extension. You can see that I'm going to add the extensions.add method and adding some additional detail into problem details class with adding the trace RD, and also if the exception is validation exception, we can also add validation errors that will populate from the validation exception.errors property. So after defining all these details, we can use the context response object in order to write these details as a JSON format. So here you can see that we perform await context response write as JSON async method in order to write these response as a problem details and JSON format in a more readable and manageable way to the client application and return the true. So this is the implementation of custom exception handler, and in this code we handle different type of the exceptions such as the validation exceptions, bad requests and others, and setting up the appropriate HTTP status code and response to problem details to the client application as a JSON format.